Hi everyone. Today we are moving to the third part of our lecture in computer networks, that is regarding ISO OSI and TCP IP models. The main contents that we are going to look in today's session are the first one regarding the different standards, next one the need for layering, third one regarding ISO OSI model and different layers that are coming in ISO OSI model, then what is meant by TCP IP model. After that we will see a comparison between TCP IP and ISO OSI model. Coming into the network standards, we know there are two type of network standards that we are commonly familiar with. The first one is the ISO OSI model and the second one is TCP IP model. Before getting into these models and the different layers, first we are going to look into what is the need of layering in this model. The first computer networks were designed with only the hardware part as the main concern and the software part was ignored at all. But this strategy no longer worked well. To reduce their design complexity, most networks are organized as a stack of layers or levels, each one built upon the one below it. The number of layers, the name of each layer, the content of each layer and the function of each layer differ from network to network. The purpose of each layer is to offer certain services to the higher layers while hiding those layers from the details of how the offered services are actually implemented. In a sense, each layer is a kind of virtual machine offering certain services to the layer above it. Here you can see an example figure of a layered architecture with 5 layers. Layer 1, layer 2, layer 3, 4, 5 like that. Now we are moving to the first model, that is ISO OSI layer. There are n number of users who use computer networks and are located over the world. So, to ensure national and worldwide data communication, systems must be developed which are compatible to communicate with each other. ISO has developed a standard for that. ISO, that is an international organization of standardization, called a model for open system interconnection and is commonly known as OSI model. The ISO OSI model is a 7-layer architecture. It defines 7 layers or levels in a complete communication system. They are the uppermost layer, the application layer, then comes the presentation, session layer, transport layer, network layer, data link layer, and finally the lowest and the bottommost one, that is the physical layer. Here you can see an overall picture of the 7-layered architecture of an ISO OSI model. Here you can see host A is communicating with host B. So the communication starts from the 7th layer of host A, that is the application layer. From that the data will transfer to the presentation, session, then transport, then comes to network, then to data link, then to physical. And from the physical layer of the host A, it will communicate to the physical layer of host B. From there the data will move to data link, network, transport, session, presentation and application, like that it will reach the destination host B. And in this figure you can also see the name of unit exchanged. In the physical layer it will be in bit format. In data link layer the name of unit exchanged, that is the format is in frame. And when we move above, that is the network layer, the name of unit exchanged or the mode of transfer of data will be in the form of packet. Above that you can see SPDU, and above that you can see again the same format SPDU, above that PPDU and above that APDU. And what is this APDU? APDU stands for Application Protocol Data Unit. PPDU stands for Presentation Protocol Data Unit. SPDU stands for Session Protocol Data Unit. Okay, so that is a layered 7-layered architecture of an ISO OSI model. Now, what are the principles behind this ISO OSI reference model and why this number of layers has become 7, not 6 or not 8? What are the principles behind that designing? That is what we are going to discuss. A layer should be created where a different abstraction is needed. The next concern was that each layer should perform a well-defined function. The function of each layer should be chosen with an eye toward defining internationally standardized protocols. The layer boundaries should be chosen to minimize the information flow across the interfaces. The number of layers should be large enough that the distinct functions need not be thrown together in the same layer out of necessity too, and small enough that architecture does not become unwieldy. So these were the consideration behind the 7-layered architecture of ISO OSI model. Now coming on to the first layer, that is the physical layer, and the functions that we are dealing, or the main duties of physical layer. And as we know, we have seen in the figure that physical layer is the lowest layer of the OSI model. It activates, maintains and deactivates the physical connection between different devices or hosts. It is responsible for transmission and reception of the unstructured raw data, that is the first level of data over network. Voltages and data rates needed for transmissions, everything like that will be defined in the physical layer. It converts digital to analog, analog to digital, etc. Then optical signals, all those type of dealings will be done in the physical layer. Data encoding is also done in this layer. So that is regarding the different functions in physical layer, that is the lowest and the bottommost layer of OSI layered architecture. Now moving on to the second one, data link layer. Data link layer synchronizes the information which is to be transmitted over the physical layer. The main function of this layer is to make sure data transfer is error-free from one node to another over the physical layer. Transmitting and receiving data frames sequentially is managed by this layer. This layer sends and expects acknowledgements for frames received and sent respectively. Resending of non-acknowledgement received frames is also handled by this particular layer. This layer establishes a logical layer between two nodes and also manages the frame traffic control over the network. It signals the transmitting node to stop when the frame buffers are full. So the data link layer will help the physical layer to do a error-free data transmission from node to node. Now coming on to the next one, that is the network layer. The network layer's main function is routing the data from one point to another point. So that is the first point that we have written here. Network layer routes the signal through different channels from one node to other. It acts as a network controller. It manages the subnet traffic. It decides by which route data should take. That means it will look on to the best route among the different alternatives that is available. It divides the outgoing messages into packets and assembles the incoming packets into messages for higher levels. So that is regarding the network layer. Now moving on to one more layer above, we are having the transport layer, that is the layer 4. Transport layer decides if data transmission should be on parallel path or single path. We usually call this transport layer as an end-to-end or host-to-host connection layer. Functions such as multiplexing, segmenting or splitting on the data are done by this particular layer. It receives messages from the session layer which is above it, convert the message into smaller units and passes it to the network layer. Transport layer can be very complex depending upon the network requirements. Transport layer breaks the original message or the data that is given to that particular layer into small units so that they are handled more efficiently by the network layer. So that is regarding the transport layer. Moving on to the fifth layer, that is session layer. Session layer's main duty is to synchronize the conversation between two different applications. Transfer of data from source to destination. Session layer streams of data are marked and are resynchronized properly so that the ends of the messages are not cut prematurely and data loss is avoided. So the synchronization factor and loss of data recovery, these are the two main issues that session layer will deal with. Coming on to the next one, layer 6, that is the presentation layer. Presentation layer takes care that the data is sent in such a way that the receiver will understand the data and will be able to use the data. That is why we are calling that particular layer as a presentation layer. Data will be given to the user in a presentable format. While receiving the data, presentation layer transforms the data to be ready for the application layer. Languages, that is the syntax and semantics, can be different of the two communication systems. Under this condition, presentation layer plays the role of a translator. It performs data compression, data encryption, data conversation, all the cryptography matters, etc. all will come under this particular presentation layer. Now we are moving to the 7th layer, that is the topmost layer, which we call as the application layer. Application layer transfers files to the user, and it also deals with mail services, directory services, network resources, etc. And these are the main services that is provided by the application layer. This layer mainly holds application programs to act upon the received and to be sent data. So that is regarding the different layers in ISO OSI model. We have seen the 7 layers starting from the physical, then comes data link, network, transport, session, presentation, and finally the 7th one, application layer. And we have seen an overview regarding the functions of these different layers. In the coming lectures, we will see each one of these layers in detail. Now moving on to the next model, TCP IP reference model. What is this TCP IP? TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. And what do you mean by protocol? Protocols, as we know, are a set of rules which govern every possible communication over a network. And this protocol describes the movement of data between the source and destination. And here you can see a layered architecture of TCP IP reference model. In ISO OSI model, we have seen 7 layers starting from the bottommost physical to the topmost application. But here we are having the first or bottommost layer, network access layer. Above that we are having internet layer. To the top of that, transport layer, and above that we are having the application layer. So this is the layered architecture of a TCP IP, that is Transmission Control Protocol and Internet Protocol reference model. Now, which are the different protocols that we have in this particular TCP IP model? That is what is shown in this particular figure. In the first layer, that is what we call as the combination of a physical layer plus data link layer. That is the first layer in TCP IP model. In that layer, we are having ARPANET, SATNet, packet radio, LAN, etc. Above that, we are having the network layer, and the main protocol that we are using there is IP, which stands for Internet Protocol. And above that, we are having the transport layer, and the two important protocols that we are using in transport layer are TCP and UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. And what is this TCP and UDP, which is connection oriented, which is connectionless? There are some differences between this TCP and UDP that we will come into in later. And above that we are having the application layer. There we are having the protocols like Telnet, FTP, which stands for File Transfer Protocol, the protocol that helps to upload and download file. Then Simple Mail Transfer Protocol, that is SMTP, and finally DNS, which stands for Domain Name System. So these are the main protocols that we are having in TCP IP model. Now the layer 1, that is host to network layer, which is the lowest layer of the all. This protocol is used to connect to the host so that packets can be sent through it. It varies from host to host and network to network. Now coming on to the next one, that is the layer 2 internet layer, which is the most important layer. Selection of a packet switching network which is based on a connectionless internetwork layer is called a internet layer. It is the layer which holds the whole architecture together. It helps the packet to travel independently to the destination. Order in which packets are received is different from the way they are sent. IP or Internet Protocol is the main protocol, or we can call it as the backbone of this particular layer. The various functions performed by the Internet layer are delivering of IP packets, performing routing, that is choosing the best route, avoiding congestion. What do you mean by congestion? Congestion is just like a traffic block. Coming on to layer 3, that is the transport layer. It decides if data transmission should be on parallel path or a single path. Functions such as multiplexing, segmenting, splitting of the data all are done in this particular transport layer. The applications can read and write to the transport layer. Transport layer also had header information to the data. It also breaks the message into smaller units so that they can be handled more efficiently by the below layer. Transport layer also arranges the packets to be sent in sequence. For that, it defines two end-to-end protocol, TCP and UDP. TCP, which stands for Transmission Control Protocol, which is a reliable connection oriented protocol. And the second one is UDP, which stands for User Datagram Protocol, which is an unreliable connection less protocol. Now coming on to the next one, that is application layer. And in application layer we have seen the different protocols that are being implemented. The first one is Telnet. It is a two-way communication protocol which allows connecting to a remote machine and run applications on a remote machine. FTP, which stands for File Transfer Protocol, which helps to transfer files, upload and download files more easily and efficiently. SMTP stands for Simple Mail Transfer Protocol, which is used to transport email between a source and a destination. DNS stands for Domain Name Server, which resolves an IP address into a textual address. For example, we are typing www.google.com for getting a Google search engine, not the IP address. So that IP address is transferred to that textual address www.google.com or yahoo.com or gmail.com with the help of this domain name server. It allows peer entities to carry conversation. So these are the different functions that are coming in layer 4 application layer. And thus we have seen what is meant by ISO OSI model, TCP IP model, the different layers in TCP IP model. Now we are going to see a comparison between ISO OSI model and TCP IP model. In the figure itself, we can see the 7-layered architecture of OSI model and a 4-layered architecture of a TCP IP model. And this data link and physical layer will function together as one layer in TCP IP model, that is the network access layer. And instead of network layer we are having an internet layer. Instead of transport layer we are having the same transport layer there in TCP IP model. And the above 3 layers, that is a session, presentation and application layer, they are combined together to one layer in TCP IP model, that is application layer. So instead of the 7-layered architecture in ISO OSI model, we are having only 4 layers in TCP IP model, starting from the network access, then the internet, then the transport, and above that the application layer. So that is the pictorial comparison between OSI model and TCP IP model. Here we can see a clear comparison between OSI model and TCP IP model. TCP IP model, as we have seen, is developed by International Standard Organization ISO. TCP IP model is developed by ARPANET, Advanced Research Project Agency Network. The next difference is that OSI model provides a clear distinction between interfaces, services and protocols through its 7-layered architecture. But TCP IP doesn't have any clear distinguishing points between services, interfaces and protocols. OSI refers to Open System Interconnection, where TCP refers to Transmission Control Protocol. The next difference is OSI uses the network layer to define a routing standards and protocol. But in TCP, TCP/IP uses only the internet layer instead of the network layer. Now, the next difference is OSI follows a vertical approach while TCP/IP follows a horizontal approach. And the next is, we know OSI layer is having a 7-layered architecture, whereas TCP/IP is having a 4-layered architecture. The next one is OSI model. Transport layer is only the connection oriented layer in the ISO OSI model. A layer of the TCP/IP model is both connection oriented and connectionless. In the ISO OSI model, the data link layer and physical link layer are separate, but in TCP/IP, physical and data link are both combined as a single host to network layer. Coming on to the next difference, session and presentation layers are a part of OSI model, but in TCP, there is no session and presentation layer. Now, OSI model is defined after the invent of internet, but TCP/IP model is defined before the advent of internet. So this is regarding the main comparison between ISO OSI model and TCP/IP model. So coming on to the conclusion of this particular lecture, we have seen different layers in ISO OSI model, starting from the first one, that is physical layer, then coming on to the next one, data link, then network, transport, session, presentation and application layer, and we have seen an overview regarding the functions of those different 7 layers. After that, we have seen the need for layering, why this ISO OSI model is layered as a 7-layered architecture. After that, we have seen TCP/IP model and different layers coming in TCP/IP model, and finally we have seen a comparison between TCP/IP model and ISO OSI model. In the next lecture, we will be dealing with the physical layer and the main functions that are coming under physical layer, mainly guided media and unguided media, regarding switching and different types of switchings like circuit switching, packet switching, message switching. After that, we will move on to DTE and DCE interfaces, 6.21 modems, etc. like that. Thank you.